Energy inside here, half a portion of it is red, a portion of it is blue. So depending on whether red by how much, blue by how much, it will change every time. So you need to go and use the equation there to find this. The others, all from steam table, you can read off straight there. Okay, so later on, we'll cover this one, how to come to find the H for this. Okay, now I'm trying to tell you these three here, HF, HFG, and HG. What are they? Okay, now. So HF, like I said, the first one is the energy when they are at stage 1. Okay, to maintain them at stage 1 here. Alright, so this is HF. And in order to reach to HG, I need, like I say, from water to a steam here, totally dry, I need to pump in more energy, right? Yes. So I pump in energy to convert to this, not enough. Some of them are still wet. I still need to pump in some more energy to convert them all into dry. This amount of energy from here to here, to get them to dry, is your HFG, from liquid to gas. Okay now? HFG is from your liquid phase to a gas phase. That's why I put FG in between from F to G. Okay now? Question? No. Okay, if you don't understand, please ask them. Okay? Okay, so that actually sounds out, clarify what is HF, HFG, what is HG. So this plus this must be equal to this, right? Yeah. Right, that's what is given in the note. Okay, that's what is given in the note. So if you look at your steam table, there are 3 columns, HF, HG, HFG, and HG. If you plus these 2, you'll get this one. Alright? So total, in order to get all totally dry, okay, I need HF plus a certain energy HFG to transform them to steam. Okay, totally dry. Any question? Okay. So once I actually reach up to here, we term this as dry steam. Dry steam means to say that all the steam just turn to dry only. Okay, at the stage where it is totally dry, that's all. Alright, okay. So at this point here, steam are totally dry, but you notice that the volume is up. Of course, as it turns to steam, it keeps on drying up, the volume expands again. Okay, but here, okay, take note, at this point when it is totally dry, it has this energy Hg here. This energy means how much energy inside here, all this dry here. Okay, enthalpy is the total energy here. Okay. So if I actually heat some more, heat this amount here further, add in some more heat, what happens? It is going to turn this into the next level superheat. Once it reaches Hg, these are dry steam. If you add heat some more, it is going to go into the next stage superheat. Okay, all right. And how do we see superheated steam? Okay, the temperature they can say that in multiple choice to see whether you're understanding. Okay, from here I draw the temperature curve here. Stage 1, from room to saturation temperature. This is boiling temperature. Stage 2 onwards, when they change from liquid to wet steam to dry steam, during this phase change from water to wet steam to dry steam, temperature remains the same.
From water to wet to dry?
Yes. Here to boiling. Okay? Then from boiling onwards, I must add on heat, right? To change it from this to this, right? During this stage of phase change, I call it phase change. You all know what is phase change, right? Phase change from liquid to gas. Okay? Though they change there, I add in energy, they change. But that energy is only to let them go from liquid to gas. Nothing else. Okay? It's for them to transform from one phase to another phase, a liquid phase to a gaseous phase. That's all. Okay? But the temperature, as they change, remains constant at saturation, 100. Let's say if water here, if this is 100, during this change to dry steam, if I add in heat, change to dry steam, it still remains at 100 degrees. Temperature never changes because it reaches its saturation, maximum for water. Okay, it's only the next thing that you add in energy, I change from liquid to gas. Okay, just like in your fridge, you have water, you put inside your freezer, what happens? The liquid change to solid, right? Correct. So that particular phase change there, okay, the temperature will maintain the same. It's just the energy level is different. Okay, there's a name given here. Okay, so this name given for the phase change from a liquid to a gas, any energy that's used to change from one phase to another is called latent heat. Two types of heat I've explained to you. One is sensible heat. When it's building up, you can feel it. The other one is called a latent heat. Okay. Latent heat is the energy that is pumped in to convert them from liquid to gas. You notice the temperature never changed, but the heat, this latent heat is the one HIP that pump in to change from phase change only. Okay, but temperature remains the same. That is why here we call it that from this, once it reaches saturation and until stage 3 here, the phase, the process is what? The temperature remains constant. Okay, so during this portion here, from stage 2 onwards, once it reaches TS until stage 3 here, okay, the process, be it water change to gas or what, any heat going in, the temperature still remain maximum TS isothermal. Yeah. Okay, so I can actually basically ask you a question like, for this temperature, what's the TS of this and TS of this? Are they the same?
Yes.
Okay, they should be the same. Okay, remember this curve here. Okay, up to dry, up to stage 3, it is still TS. But just now what I say, when it reaches all dry here, if I pump in some more heat, what happens? It will expand even further, more energy to go into superheated. Once it goes over this stage 3, it will no more behave isothermally. Okay? Once it goes into stage 3 onwards, this is the maximum I can go. If you pump in some more heat, my temperature is going to rise. Okay? And when the temperature rises, it goes into superheated region, stage 4. And you notice that superheat, okay, the steam actually further expands. So if you compare, this one is x equals to 1, right? This one also x equals to 1, right? But the Hg and the H here is totally different. This one, the H over here, Hg is only this amount. But you notice this thing expanded so much. So the amount of energy inside a superheated is so much higher compared to a Hg, a dry gas. Okay now?
Yes.
So one question is, you have to know that superheat will only occur when the temperature is above. For a given pressure, the temperature is above saturation. Okay? So for that condition, let's say for your condition, just now you measure the temperature. Okay, if the steam temperature is above 100 degrees, okay, 110. Okay, so what do you think?
Superheated.
You will go into superheat. Okay? For this pressure here, maximum it goes up to here, you will dry. Okay, but if it actually, for the same pressure, 1.013 bar atmospheric pressure, if it goes above 100, that means it is in superheat now. Okay now? Okay? So I just want you got steam table, right?
Yes.
Yes.
Okay, I just want to give you one example. Okay, to let you see how we see all this steam here. Okay, a liquid heated at a pressure, it is heated up. This liquid is heated up. Okay, all this can I erase or not?
Can, sir, can.
Can, huh? Yeah, I run out of paper. Normally 3 board, I will use all 3 boards. Okay, I just want to give you one example to let you know how to see what stage they are in and when is it in a superheated steam column there. Okay, for a liquid being heated up, okay, at a pressure, okay, at a pressure of 11 bar pressure.
11 bar.
Okay, absolute. Here the pressure is all absolute pressure, but you don't need to go and add in the 1.013. It's all added in already, steam table. Okay. So in your lab experiment, when you want to use a steam table, you must convert them to absolute pressure. Then you look onto your steam table. Okay? So at 11 bar, okay, this liquid is heated up to a temperature of
94.1.
No, I haven't even said that. Okay? 200 degrees centigrade. Okay? The liquid at 11 bar pressure, absolute, is heated to a temperature of 200 degrees centigrade. Okay, so you look at the saturated water and steam, you look for 11 bar. At 11 bar, at P equals to 11 bar, what should be the TS? 184.1 degrees C, right? So based on this, the TS is 184.1, right? But now the temperature is 200. You notice that the temperature is higher than this, right? So this steam heated at this temperature here is at stage 4, superheat steam. Okay, so based on this, I give you this, you'll know. You check a steam table at 11 bar, normally things boil at this. But now this thing can go above the boiling, that means it must, the only way it can go is to go to stage 4. Okay? 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 Any question?
No.
No? So when I give you pressure and all this sort of thing, when you read your steam table, you must know what stage they are in.
Right.
Alright? So if I give you at 11 bar pressure, now the temperature is at 150 degrees C.
Stage 1. Stage 1.
Now it's at 150 degrees C. Liquid at 11 bar is heated up to 150 degrees C. So what stage is that? Why?
Because it happens with the boiling.
Yeah, because this one, the TS is 180, right? 184, right? So here, before it reaches 184, it is still in between here, right? So it must be stage 1. Okay, this is stage 1. Okay, if you can understand this, to know all this, 3/4 of your battle is very wonderful. Okay, you find the calculation for steam is very simple. Sure nap, short, sure get. Okay, if you understand all this, your calculation sure to get the money. Okay, now, any question? No. The problem now is that when I explain all this, you all don't understand. That's the thing. Anyone? Any question?
No, sir.
Okay, so I already told you how to see what stage they are in. Alright? And now the only thing is if I give you this, okay, if I give you this, okay, water heated at 11 bar, water heated at 11 bar and has a dryness fraction of 0.8.
Stage 2.
So when I tell you this and this, you know that this is another stage. This is wet steam. Okay, it is now it is totally steam, but 80% dry, 20% wet. Okay now, right? So how to find? Look here. The last thing I need to tell you here is that over at stage 1, you know it's HF.
Yeah.
The total energy here is HF. Over at stage 3 here, the energy of this steam here is Hg. Correct? Okay? And over at superheat here, the term given here is just H. H for superheat.
Specific.
Alright? And what is the total amount of energy inside here?
Hg minus Hf.
This is X, right? So in your book, to denote stage 2, they call it the total energy inside here, I term as Hx. Okay now. So this is the total energy with a dryness fraction stage 2. Okay, and you notice that only Hx has an equation. What is this?
HF plus S times HFG.
Correct? So only at this portion, if you want to find what is the total energy inside here, you need to know what is the portion of dry, which is actually this. So this one, if I give you this, is going to be 0.8, right? Okay, and can you find your HFG and your HF?
Yes.
You can find from 11 bar, right? Okay, substitute inside here, and you can get your HX over here.
Yes.
Okay.
Yes.
Any question on this? No?
You want to ask question, ask him macam.
No, seriously, any question? I'm here to entertain your questions, to let you know all this. Practically, I covered the whole topic already. Right?
Tidak keluar dah lambat.
Okay? I don't have your note, but my picture, every semester, my picture tells 1,000 words. Okay?
HF from
Sorry?
the HF from table, is it look at the saturated water or the superheated?
Which one? This one here is under which one?
Saturated lah.
Saturated water.
So you look at saturated.
Yes. All these over here, look here, 1, 2, and 3, all under saturated water and steam. Only this one, you go into superheat.
Superheat basic.
Okay now, okay? So very simple, the first 3 over here, all on saturated water and steam. Then this one, superheat.
Okay.
Okay, if nothing over here, this one is okay. The last thing that I need to cover with you is your degree of superheat. Okay? When this term, degree of superheat, okay, if you notice all these terms are used in your notes, okay?
Yes.
Since I'm here, I just cover this. When I ask you in your exam to find the degree of superheat here, okay, like example just now, the other one here, okay, and the temperature of 200 degrees C. This one just now, example superheat, right?
Yes.
What's the TS there?
184.1.
TS for this is equal to what? 184.1 degrees C. So your degree of superheat means the difference between your superheat and your saturation temperature here, the temperature here and here. So your degree of superheat equals to your T minus your
TS.
15.9.
Okay?
E minus TS. Okay.
Alright. So this one you need to know
16.
because once you come to superheat, if they ask you what's the degree of superheat, that means the difference. How much different from the current superheat temperature to your saturation temperature? Okay? And I hope you all know when I say latent heat of vaporization now. You all know what is latent heat?
Yeah.
What is latent heat used for?
For dry steam to superheated steam.
For boiling.
Latent heat is the heat energy used to change from liquid phase to a gaseous phase. Okay now? Use. Okay. So sensible heat is the heat to raise it from room to
DS.
boiling or saturation. Okay. We have latent heat of vaporization, which is here to here.
Vaporize the water.
Right now. So your latent heat is where? Your latent heat is actually your HFG here. Okay, this amount of heat added in to raise them from this wet to gas. Okay, so this amount of heat is called latent heat of vaporization because it's vaporizer. But in freezing, water to ice, that one also latent heat. You take out the amount of heat there to turn it to ice. Okay, that amount of heat taken out is also called a latent heat of fusion. Okay, alright, this is latent heat of vaporization. Okay, so now when you learn the name here, latent heat. This word latent heat is to change phase from liquid to solid or solid to liquid or gas. Okay now? Okay, no questions, that's all I can. You all can carry on. If you really understand how to do this, carry on with your lab now. You can carry on with your tutorial. You should be able to finish the tutorial.